In this video, we're going to learn how to use the calculator for the permutations rule and the combinations rule. So I've got an example of each, and on your calculator, let's see, the permutations rule, when all items are different, is noted in PR equals n factorial over n minus r factorial equals the number of different permutations where order counts when n different items are available, but only r of them are selected without replacement. So on our example, the probability of winning the main lottery is 1 out of 5,245,786. This is when the numbers can be in any order. What's the probability of winning if the rules are changed so that in addition to selecting the 6 correct numbers from 1 to 42, you must also select them in the order they are drawn? So what we're doing, we're going to choose 6 numbers out of these 42. And we want it to be a permutation this time where order matters. So on your calculator, the calculator reads it, has it the same as NPR. We have to type the number n in first. So we have n total objects, which are 42 numbers in the main lottery. Then we're going to go pick up the NPR. So click on Math. The last option over here is Probability. Use the arrow keys to get there. NPR is the second option. So arrow down and enter. So it'll type 42 NPR, and we have 6 numbers that we can select out of the 46 for the lottery. Hit enter, and that's our number. So that would be a huge number. 3,776,965,920. So our odds of winning, chances of winning the lottery, if order is important, is 1 out of that number. Pretty much impossible. Alright, so that's where NPR is. That formula is programmed in your calculator. Next item is combinations rule, and this is number of different combinations where order does not count when n different items are available, but only if r of them are selected without replacement. So I'll have you do this example in a minute. But if you wondered where they got this probability of winning Maine is 1 out of 5,245,786, that's a combination because you can actually get your numbers in any order. So if you select 42, hit the Math key, over to Probability, in CR, we're selecting 6 numbers. That's where the 5 million value came from. So the difference between these two, if you took this number up here and divided it by the total number of ways you could arrange 6 objects, then that's where you would end up with the 5 million. Alright, so let's try our next example. Walton Pharmaceuticals wants to test the effectiveness of a new drug designed to relieve allergy symptoms. The initial test will be conducted by treating 6 people chosen from a pool of 15 volunteers. If the treatment group is randomly selected, what is the probability it consists of the 6 youngest people in the pool? And then if the 6 youngest are selected, do you think it was random or were they selected based on age? Alright, this time we have 15 volunteers. Order does not matter, we just want the 6 youngest in any order, or that's what we want probability of. So this would be, hit the Math key, over to Probability, a combination, 15 people, 6 chosen at a time. We end up with 5,005, so our probability would be 1 divided by 5,005. Alright, so that would be 1.998 times, this means times 10 to the negative 4. That means we would move our decimal 4 units back. Our probability would be 0.0001998. So the probability that we end up with the 6 youngest is very, very small. It would be unusual for that to happen randomly. If we selected the 6 random, it would probably be on purpose. All right.